Hello class. So here is your first ed puzzle lesson. The first thing that I want to do today is just a quick review of the exponent properties that we've been covering. So the first one here is when we multiply powers with the same base, what are we supposed to do with their exponents? And that is we add them. One quick thing that I want to talk about this particular property, because there were some questions that came up you may not have had questions, but whenever I graded your work, I noticed that a few mistakes were being made with something like this. So I just want to point it out to you. So first, these ones that don't have exponents, remember, they're just understood to be raised to the first power. And with these two numbers, 2 to the first and 4 to the first, they're evaluated already because 2 to the first is 2 and 4 to the first is 4. If there was a different exponent, we'd want to do that first, but 2 and 4 are not the same base. So we would not add the exponents. We would simply just multiply 2 times 4 and get the answer 8. And then we would use the property on x to the first and x squared because those have the same base, so therefore we would add the exponents. All right, the next property is when we have a power being raised to another exponent. So what do we do with the exponents? And that is we multiply them. Okay, and then finally, the property that we went over yesterday, just noticed I wrote that wrong, so let me change that. Should be a to the n here. So when we're dividing powers that have the same base, because that's the only time that that property will work, what do we do with the exponents? We subtract them. And we always start with the numerator's exponent, and then we minus the denominators, okay? So, and then this is just like over 1, you know, and then we're going to talk about, well, what will happen if you get a negative exponent, and that's what we're going to talk about today. So again, section 8.4 is about 0 and negative exponents, and to understand these rules, I just always like looking at patterns. It helps us remember it and understand why the rule is the way that it is. So here I just went ahead and started 2 to the 5th is 32, 2 to the 4th is 16, 2 to the 3rd would be 8, 2 to the 2nd is 4, and 2 to the 1st is 2. Okay, over here, 3 to the 5th is 243, 3 to the 4th is 81, 3 to the 3rd is 27, 3 to the 2nd is 9, and 3 to the 1st is 3. Okay, so what we want to do is try to find a pattern so that we can continue down here at the bottom to get 2 to the 0, 3 to the 0, and then to the negative 1, and negative 2 powers. So what we're going to do is look at the answer up here. And first of all, if you notice, all of these have the same base, and I am decreasing the exponent by 1 each time. So there's a definite pattern. So with the answer, what the pattern is if you divide by 2. Okay, and so if we continue that pattern, because we went from 2 to the 1st, and if we decrease it, it's 2 to the 0 power, then that would just mean we would divide by 2. So 2 divided by 2 is 1, and that is indeed what 2 to the 0 power is. Even if you put it in your calculator, you can check me. If you put in 2 raised to the 0 power, it equals 1. All right, and then we'll come over here to the powers of 3. And again, we're decreasing by 1 each time with the exponent. So what do you think is the pattern with the answer? So if we went from 243 to 81, or 81 to 27, and so on. It is that we're dividing by 3 each time. Which should make sense because, you know, we're decreasing how many times we're multiplying by 3. So if that holds true, then that would mean that 3 to the 0 is 1. And that is the definition of the 0 exponent. Any number raised to the 0 power is 1. Okay? The only thing is I want you to remember is if there's a negative, if it's included in the base, like this would equal positive 1. If it's not included in the base, just like with other powers, then this answer would be negative 1. Okay? All right, moving on. So we're going to continue with the pattern. Remember, we just don't change the pattern. There's a definite pattern, so we decrease by 1 with the exponent, so it's 2 to the negative 1. So if we divide 1 by 2, we're not going to write it as a decimal because it makes it harder to see what's happening. So we're going to write it as a fraction. So 1 divided by 2 would be 1/2. And then if we divide 1/2 by 2, I'm not going to do that math, it's 1/4. Okay. Now, do you notice anything about these answers? Well, hopefully you notice that if we were to write this as 1/2 to the first, that is what it is. And here, if we were to write it as 1/2 squared, that is the answer 1/4. Okay, and that is the definition, or the operation I like to call it, of the negative exponent. Okay, we'll look at one other set of patterns so you can see it works with any base. So over here with the 3, so if we divide 1 by 3, then written as a fraction, that's 1/3, which that would be the same as 1/3 to the first. And if we divide 1/3 by 3, we get 1/9, which is the same thing as 1/3 to the second. Okay, so here are the definition of the 0 and negative exponents. So for any number that's not 0 raised to the 0 power, the answer is 1. Okay, so the only reason why it says non-zero number is that 0 to the 0 is undefined, and I'll talk about that on another lesson, just not right now. So there won't be any kind of questions like that for you to deal with. Okay, then we deal with the negative exponent rule. Okay, and basically I like to say it tells you to reciprocate the base. So if you have a number raised to a negative exponent, then it means that it's going to take that number and reciprocate it. So that means if it's in a numerator, like this first one here in the middle, it sends it down to the denominator. And then once you've done the operation of the negative exponent, you no longer have a negative sign in front of that. Okay? Okay, and then here, if your exponent is negative and it's in a base, then it reciprocates to the numerator. That's what it tells it to do. So it sends it from either the numerator to the denominator or the denominator to the numerator. Okay? All right, we're going to do a couple of practice problems here. I suggest you kind of ride along with me on your own paper so you can look back at them without having to go through and replay this, because you can't fast forward with Edpuzzle. So the first one here is 3 to the negative 2, which I know you already know from our practice, but the way that you would go about doing this is, if it's raised to a negative exponent, the first thing you want to take care of is that. So that means we need to reciprocate what's being raised to the negative exponent. So it would be 1/3 to the second. Notice once I've done that operation, the 2 is no longer negative, and then I just treat it like I always do for evaluating. So 1/3 to the second is 9. And that's another thing today. We're going to fully evaluate or simplify. So we're not going to leave things written as powers as we did in the exercises from the last section. All right, next question. 1,000,002 raised to the 0 power. What would this equal? 1. Okay. All right. Now, on to a little bit more challenging question. So we'll start here with A, 3 times y to the negative 2. So remember, we still want to use those little things that help us out. So if there's not an exponent, put the 1 there so you can see it. 3 is being raised to the first power. It's not being raised to the negative power. The only thing raised to the negative is the y. So that means that the answer is, well, 3 to the first is just 3, and I can't simplify that any further, so it's going to remain 3. This y being raised to the negative 2, since it's raised to a negative exponent, it sends it to the denominator. So this would be the final answer. Okay. All right, part B. And I strongly suggest you piece it out, as you look at each one. So if I'm looking at this first, m to the 0, and we're just going to assume that m would not be 0. That means that m to the 0 is 1. And then 1 times n to the 5th. And you can leave it like that, or if you just want to write it as m to the 5th. Okay? All right, part C. A to the negative 7 times b to the 3rd. Okay, so this would equal a to the negative 7 means that it's going to be sent down to the denominator. And then b to the 3rd is not to the negative, so it just stays in the numerator. Okay, and then the last one, again, I'm just going to go through and put the 1s for where I don't see exponents, and then go from there. So 16 is not being raised to a negative exponent, so it's going to stay because there's nothing else to do with it. X to the negative 6 is going to be sent down to the denominator. And then y to the first is staying in the numerator. Okay. All right, now on to some examples like what you will see on your assignment. So starting here with 5 to the 5th divided by 5 to the 8th. Remember, we are going to be fully evaluating and simplifying today, so we will not just leave our answers in power form. Okay, so first of all, don't forget what you already know. So the first step in simplifying this would be to apply the quotient property. So that means I am going to do what with the exponents? I'm going to subtract them. And remember, you always start with the numerator, and I'm just going to write it out here. Okay? So 5 minus 8, which equals 5 to the negative 3. Okay? Now, we never ever leave exponents as negative unless we're writing things in scientific notation, which we're not right now. Okay, so it's just not allowed. It's considered not simplified if you leave a negative exponent. So we apply what we've learned in today's lesson. So 5 to the negative 3 would be 1 over 5 to the 3rd. And then we finish by evaluating that to 1 over 125. Okay? So about the only step, like as far as showing your work that you could maybe skip is this one. I should see all of this for a question like this because it's the only way that you're going to be able to answer these. Don't be trying to do the least amount possible because all that means is you're not really going to understand it later. All right, next example, 5 to the 0 times 2 to the 4th. So first thing is 5 to the 0 equals 1 times 2 to the 4th is 16. So the final answer is 16. All right, next example. So this one, all of these have a base of 3. So we're just going to go back to order of operations. And if this were an order of operation, this is acting like this fraction bar is acting like a grouping symbol. So we need to have everything in the numerator simplified. The denominator is already simplified. So our first step would be to multiply 3 squared times 3 to the negative 2. So what rule do we apply? It is multiplying powers of the same base, so therefore we would add the exponents. And 2 plus negative 1 is 1. Divided by, we just bring over 3 to the 5th. And now we do the law that we learned yesterday. So we're dividing powers of the same base, so we subtract the exponents starting with the numerator, 1 minus 5, which gives us 3 to the negative 4. And then we want to do the negative exponent law, which sends that to the denominator. And then we just evaluate that for the final answer of 1 over 81. All right, our next example is now we're dealing with some exponents. So the directions say, instead of saying evaluate, would say simplify. So here we go. So this would have an exponent of 1. This would have an exponent of 1. This would have an exponent of 1. Okay? Always remember to do those little things that we've been doing all along. All of this is multiplying. So negative 2 to the first is simplified as much as possible. 4 to the first is simplified as much as possible. So we would just treat them, they don't have the same base, so we're not using an exponent law. We're just going to treat them as we always have and multiply negative 2 times 4, which is negative 8. All right, then we have, all of this is multiplication, so I'm going to choose to multiply this and this times each other. So that would give us x to the 4th. And then y to the first times y to the negative 3 would be y to the negative 4 would be y to the negative 3. All right, and then finally, the only thing that we need to deal with is this negative exponent. So the negative 8 is to the first power. So it's to a positive exponent, so it stays in the numerator. X to the 4th is a positive exponent, it stays in the numerator. But the y to the negative 3 is going to be sent down to the denominator. Okay, next example. So we have 3 to the first, n to the negative 2, divided by n to the third. So the first thing we're going to do is we're dividing powers with the same base. So remember, we subtract exponents. So we just bring over 3 to the first, and then it's going to be n to the negative 2 minus 3, which is 3 to the first times n to the negative 5. And so our final answer would be 3 over n to the 5th. All right, guys, this is our last example. So we got a little bit more going on here, but remember the fraction bar is acting like a grouping symbol, so we want to make sure everything's simplified before we start doing any division. So the first thing I notice is that this 2 is being raised to the negative 3 power. So that means it goes down to the denominator. So it would be 2 to the third. And then m to the 0 is just 1. So I'll put a 1 here. Times n to the 8th. And then I'll just bring over n to the negative 2. Okay. Then I'm just going to keep putting this 1 here in the numerator. N to the 8th divided by n to the negative 2. That would be n to the 8 minus negative 2. And then 2 to the third power is just 8. So to finish up this question, we would have this becomes plus, and then it would be 1 n to the 10th over 8. Which is the same thing as n to the 10th over 8 as well.